Hey everybody, welcome back to another episode of Mr. Fincham's Fireside Follow-Alongs, and today we're going to be continuing on with our science book. So, you guys can follow along with me on your iPad or whatever device you're using, or you can follow along in your science book. We are on page 286. It's Unit 4, Lesson 2, Why is the Sun Brighter Than Other Stars? And as always, it's helpful to me, it might be helpful to you, that when you are having your science textbook out on your iPad or on your computer, that you can click the main ideas star up top. This section doesn't have any, but I just wanted to remind you guys that when you click it, it'll highlight the main idea of each section and each page. So, the last time we read our science book, we were talking about gravity, how gravity is pulling you towards the center of the Earth. Talked a little bit about meteorites, things like that. So today we're going to switch gears just a little bit, and we're going to talk about the sun. As we have discussed in my class, and I'm sure in all of the other 5th grade classes, we know that the sun is nothing more than a star. The sun is a star, right? But why is our sun brighter than other stars? That's the question, or one of the questions, that we're going to be tackling today. So, we are going to start off on the first paragraph. On a clear night, you might look up at the sky and see thousands of glimmering stars. You will discover how stars give off light and that several factors affect how bright they look. The distance between most stars and Earth is so great, scientists measure it in a different way than they measure things on Earth. So what they're saying there is that the distance between most stars and the Earth is so large that we can't use the same things we use on Earth to measure it. We can't use a ruler, right? You would have to use something very different to measure it. So here is a little activity that you guys can use about the sun. What do you see in this image? Is the sun the only star in the sky during the day at night? Why do you think the sun looks bigger and brighter than the other stars? You guys can feel free to mess around with that on page 286. Now we're going to go on to 287. Let's click the main idea thing here. Notice how some of the text comes up in bluish purple. All right, we're going to start section 1. Light from stars travels to Earth. When you look up at the night sky, you probably see glimmering stars. They look like tiny points of light. What makes stars look like tiny points of light? Because stars are so hot, their energy produces bright light. This energy comes from the center, or core, of the star. Slowly, the light travels from the star's core to its surface. From the surface, light travels outside of the star into space, where there is little matter. The light travels in straight lines, or rays, in all directions away from the star until it hits some form of matter. As light rays move far away from a star, the rays spread out over more and more space. So, when a star is very far away, only a small portion of the light reaches Earth. The rest of the light spreads out in different directions. So notice these images here. This is kind of what it looks like if somebody is shining a flashlight at you, right? You see the rays come out in all directions, and then you see the most concentrated coming from the center. Same thing with the stars. So let's read the caption of this picture. The farther that light from a star travels, the more the light rays spread out. So, star A would look brighter from Earth than stars B and C. This is because star A is the closest to the 3 Earth, or of the 3 to Earth. So, the same thing with a flashlight. If somebody is pointing it at you and you're very close, it's going to be extremely bright. But if somebody is pointing it at you from, 50 yards away, it's not going to be as bright because you're further away from the light, right? Next paragraph. The sun looks so big compared to the other stars because it is the closest to Earth. This means light rays from the sun do not spread as far as rays from other stars before they reach Earth. This is why the sun appears brighter than the other stars. At night, when the sun is not visible, you can look up at the night sky and see hundreds or even thousands of stars, too many to count. Each star looks like a tiny point of light. But, as you have learned, stars only look small and dim because they are so far away. So, only a very small portion of the light reaches Earth. So when you look up at the sky at night and you see the stars, some of them are very, very faint. They're not very bright, right? Mostly that's because they're so far away. And the sun, it illuminates everything in the daytime, right? It's the reason we have day. The reason for that is because the sun is so close. It's so close to us. I know a lot of you have laser pointers. I've definitely seen some in my classroom this year. So, if you are shining a laser pointer at somebody who is just a foot away from you, you're going to be able to see the red dot on them very, very clearly. Okay? Now, imagine you're pointing it at somebody on the opposite end of a football field. You may be able to see just a very faint red light, barely at all, or maybe not even. That's because of the distance. You're so far away. So, this is a little activity for you guys to do to check your understanding. There's 7 quick multiple choice questions on here. Remember, when you guys are doing this, use your POE strategy, the process of elimination. If you're not sure the correct answer, that's okay. Hunt out the ones you think are incorrect. Right now, if you're just guessing, which you really kind of shouldn't be doing, but if you are, you have a 25% chance of getting it correct. If you find one of these answers that you know is incorrect, cross it off. Then you're only working with 3. That means you have a 33% chance of getting it correct. So for every wrong answer you can find, your chance of being correct goes up. Okay? Use that strategy. There's some other little activities down here at the bottom. Why do stars farther from Earth appear dimmer than stars closer to Earth? And then these are the terms you're going to need to use in your answer. Light rays, brighter, dimmer, distance. And number 2, explain why the sun appears to be so much brighter than other stars we can see on Earth. And now we're going to go to the next section. Okay, so this is page 288. Again, we're going to hit the main idea button. I always like to have it on. Number 2. Measuring distance in space. You use different units to measure different distances. You may live only steps away from your neighbor. That distance might be measured in meters. But you might use kilometers to explain how far away the next town is. What unit do scientists use to measure distance between stars? Whoops, next paragraph. Distances between stars are much larger than a few meters or kilometers. In fact, the distances are so large that everyday units are too small to describe them easily. Instead, scientists use a unit called a light year. A light year is the distance that light travels in 1 year. The word light year sounds like a unit of time, but it is actually a unit of distance. It is similar to saying that your school is a 10-minute walk from home. You know how far you can walk in 10 minutes. That distance is a 10-minute walk. In the same way, light needs a whole year to travel about 9.5 trillion kilometers, which is 1 light year. Sirius is 8.6 light years away, so it takes light 8.6 years to reach Earth from Sirius. So here's the comparing distances. So the sun, in order for the sun's light to get to Earth, it takes about 8 minutes. 8 minutes, and the light that's coming off of the sun will hit Earth. 8 minutes. Now, if we want the sun's light to come to Sirius, it takes 8.6 light years. Because distances in space are so great, scientists use a special unit called a light year. Light years are used to measure distances between stars or the distance between Earth and a star, such as Sirius. Next paragraph. Light travels faster than anything else. It moves so fast, you cannot even see that it's moving. The light from a lamp seems to reach you instantly when you turn on the switch, but light takes longer to travel greater distances. Light from the sun travels for more than 8 minutes before it reaches Earth. So, if another space object near the sun blocks out the sun's light, it would take more than 8 minutes for people on Earth to know. So another way of saying that is, let's pretend for a second the sun goes out. It's extinguished. We would not know that happened until 8 minutes, because light is still traveling from the sun towards us, so we wouldn't know that the sun had gone out. And if we scroll down here, there are some more short answers for you guys to do. What are light years, and why do scientists use them? Number 2. Why does it make sense to estimate that the sun is 0 light years from Earth? Does this mean that the sun is close to Earth? And number 3. A star called Betelgeuse is 643 light years away from Earth. This is 6 800ths times 1,015 kilometers from Earth. Write this number in a standard form. A little math for you guys too. So we're going to go on to the next section. We only got a couple more minutes. We'll be wrapping it up here shortly. Again, I'm going to click my main ideas tab just to keep those things in my mind. And here's a little chart for you guys. As this chart shows, stars are different distances away from Earth. So LY stands for light years. So these are different stars, and this shows how far away they are from Earth. Section 3. Distance affects a star's apparent brightness. There are billions upon billions of stars in space. On a clear night, you can easily spot some stars in the sky. They are bright against the dark night sky. But most stars are harder to see. These stars are much dimmer. The apparent brightness of a star is a measure of how bright it looks from Earth. One factor that affects a star's brightness is how far away it is from Earth. This is why the sun is so much brighter than other stars. Compared to other stars, it is very close to Earth. This goes back to the flashlight analogy that I was making. A flashlight is going to look extremely bright if somebody's holding it in your face, but if somebody is holding it on the opposite side of a football field, it's not going to be as bright because of distance. Next paragraph. Although all other stars are very far away from the sun, some stars are closer than others. One of the closest stars is called Alpha Centauri A. It is about 4.3 light years away from both Earth and the sun. This means the light you see left the star 4.3 years ago. So, Alpha Centauri A is much farther from Earth than the sun. Most stars are much farther away than Alpha Centauri. They are up to tens of thousands of light years away, or even farther. So, I think I've said this before in class, that some stars are so far away that they could go out. The star could die or collapse, what have you, and we wouldn't know about it for years because the light is still traveling from it. Okay? Next paragraph. Stars that are a great distance from Earth look dimmer than stars that are closer. This is because the farther light travels, the more it spreads out. Less of their light reaches Earth, so their apparent brightness is lower. The sun is so close that its apparent brightness is enough to light up the sky. More of its light falls on Earth than does the light of the other stars. Alpha Centauri A gives off about as much light as the sun, but at 4.3 light years away, it only looks like a tiny bright dot in the night sky. Most stars are so far away by the time their light reaches Earth, it is spread out so they cannot be seen with a telescope. So here is the sun, okay? It's illuminating everything. Everything on Earth, it's literally creating our daytime. Now, here's Alpha Centauri A. Both stars are about the same brightness, right? About the same brightness. But this star, the sun, is lighting up the Earth because it's closer than this one is. So here is some more check for understanding questions, multiple choice. There's 5 of them. Please make sure to use your PO strategy, your process of elimination. And what is apparent brightness? Why is it hard to tell how bright a star really is? So if I buy 2 of the same flashlight, and I have one pointed at you from 5 feet away, and I have the other flashlight pointed at you from 100 feet away, do they look the same brightness? No, they're not going to. Are they the same brightness though? Yeah, it's the same flashlight. So why does one look brighter than the other? And here's a little diagram for you guys down here. The 2 stars in the diagram below are the exact same size, but they will look different from Earth. For A, label the star that will appear brighter by writing brighter near it. Label the star that will appear dimmer by writing dimmer near it. And then you're going to support your answer by drawing rays of light from each star. And we're going to go to the next section here. Okay, and again, we're going to click our main ideas tab here. Let me check. Okay. 290. All right, so number 4. Other factors affect a star's apparent brightness. Distance is not the only factor that affects a star's apparent brightness. There are 2 other factors. So, read this caption here. Each star is pictured as if it were the same distance from Earth. The size of the star affects its apparent brightness. The Sun is bigger than Proxima Centauri, so it looks brighter from Earth. But it is smaller than Betelgeuse, so it looks dimmer. So the size. Picture a flashlight, a normal flashlight. Is that going to give off the same amount of light as a spotlight, like the spotlight that helicopters use, or the searchlight that is used to call Batman? Probably not, right? Because the size is different. Next paragraph. A second factor that affects a star's apparent brightness is size. Large stars are brighter than small stars. A star's size is distributed by its radius. The radius of a ball-shaped object, such as a star, is the distance from its center to the outside. The star Proxima Centauri is small. Its radius is about 100,000 kilometers, or 62,100 miles. Betelgeuse is one of the largest stars known. Its radius is at least 90 million kilometers, or 56 million miles. The Sun is bigger than Proxima Centauri, but smaller than Betelgeuse. The Sun's radius is about 700,000 kilometers, or 435,000 miles. As a result, the Sun is brighter than Proxima Centauri, and Betelgeuse is brighter than the Sun. Next paragraph. Sorry guys, I've been saying Betelgeuse, but I think it's Betelgeuse. A star's temperature also affects its apparent brightness. Hotter stars are brighter than cooler stars. Scientists use a star's color to measure its temperature. Blue stars are the hottest. White stars are also very hot. Sometimes stars are considered more than one color. The star Rigel is a blue-white star. Rigel's temperature is almost 11,000 degrees Celsius, or about 20,000 degrees Fahrenheit. Red stars are cooler. A red star can have a temperature of about 2,500 degrees Celsius, or 4,500 degrees Fahrenheit. Yellow and orange stars have medium temperatures. The Sun is a yellow star and is about 5,500 degrees Celsius, or 10,000 degrees Fahrenheit. So, the blue-white Rigel is brighter than the Sun, and the Sun is brighter than a red star. Here's another check your understanding. This is a vocab one, so you're going to read the question, or the paragraph rather, and you're going to enter in the correct vocabulary words, and then you're going to check your answers. So here's another activity for you. Suppose your parent or guardian took you on a camping trip far away from the city's lights. One night you looked into the night sky and you both noticed some bright stars and some dim stars. Now is your chance to shine. How would you explain the apparent brightness of stars? Make sure to discuss all 3 factors you learned about. And we're going to go to our last page, the summary. All right. So, lesson summary. Why is the star brighter than other stars? Number 1. Light from stars travels to Earth. Stars give off energy in the form of light. This light spreads out in all directions. As the light moves away from a star, it spreads out over more and more space. So when a star is very far away, only a tiny amount of its light reaches Earth. The sun looks bigger and brighter than the other stars because it is closer to Earth. Number 2. Measuring distances in space. Distances between the sun and other stars are measured in units called light years. 1 light year is the distance light can travel in 1 year. The sun is much less than 1 light year away from Earth. It is only about 8 light minutes away from Earth. This means it takes about 8 minutes for light from the sun to travel to Earth. Despite sounding like a measurement of time, a light year is a measure of distance. Number 3. Distance affects a star's apparent brightness. The apparent brightness of a star is a measure of how bright it looks from Earth. One factor that affects a star's apparent brightness is its distance from Earth. The sun is close to Earth, so it has a greater apparent brightness than other stars. Stars that are farther have a lower apparent brightness and look dimmer. This is because light spreads out more the farther it travels. And number 4. Other factors affect a star's apparent brightness. 2 other factors that affect a star's apparent brightness are its size and its temperature. A star's size is described as its radius, or its distance from its center to the outside. From Earth, larger stars appear brighter than smaller stars. Hotter stars also appear brighter than cooler stars. Scientists use a star's color to measure its temperature. Blue stars are the hottest, the red stars are the coolest. So, blue stars are hotter than red stars. And here's another vocabulary to check your understanding. You're going to just drag each term to the definition, the correct definition. Now, as always, there is a little assignment for today's reading, and it can be found on your ELA questions and tasks. And here it is. After reading the assigned text for the day, you will create a graphic to show what you learned. You can use SeeSaw, Keynote, Pages, or other apps that you have, or a blank sheet of paper for this assignment. You will create an image that represents what you learned today in your science reading. Items you have to include in your graphic are, there are 3 things you have to include. A title that represents the overarching main idea of what you read. The second, include 4 key facts or quotes from the text in your image. So some people like to use these to border their drawing. And the last one, include an image either drawn or a graphic you obtained somewhere else. You are allowed to include any additional items you would like. The point of this activity is to use your creative side to show what you learned. So I am excited to see the artwork that you guys provide. You guys did a great job last time of sharing your art with me. As always, leave some comments in the section below. Let me know what you think. If you have any questions, any wonderings, write me on SeeSaw, email me. I am going to be interested to see what you guys think of what we learned about so far. With that in mind, I will let you guys go, and I will see you next time. Bye-bye.